Good morning. Welcome aboard Classifying Functions. Anyway, let's first take a look at the broad category polynomials. Anyways, and what's a polynomial? How do you identify one without a graph? Stuff like this. They never have a variable in the denominator is one important thing. And there's a lot of constant types. We do consider the function, or y equals -2, f of x equals -2, a polynomial. They're called constant functions. Why are they called constant functions? If you graph them, what would they look like? Okay, I see the arm motion. So this one here, for example, -2, well, I guess I couldn't fit it on this axis here. If this is your xy axis, y equals -2 would just be a straight line to the left and to the right. When x equals -5, -2 is the answer. When x equals plus 17, -2 is the answer. Hello. If you have that assignment handy, that'll be great. Then I'll try to correct it quickly. Linear functions. The degree is 1. Have you guys ever talked about something called multiplicity of the zeros too? Yeah. That just refers to the degree if you factor them, so on. Anyways, the degree is 1, x to the 1, highest power. mx plus b form, I gave that. It doesn't have to be an mx plus b form to be a linear equation. You could have had 3y minus 2x equals -3 or something like that too. Quadratic functions, degree 2, right? Whether it's factored, sometimes you'll see a function quadratic quite often actually, given in factored form. But you can imagine if you multiplied out the two brackets, you'd have an x squared. Cubic functions, degree 3. I gave an easy one there, but it could have many terms in it, right? Okay. Quartic functions, degree 4, and anything higher too as well. We don't necessarily have names for them, degree 5, degree 6, as long as there's no division, no x to the -2 or something. Power functions are just monomials, like one term, 3x to the 6, or x. We'll keep it to just like x squared, x cubed. So they're pretty easy then. We'll call that a power function. It is a polynomial, but more specific type. Power functions. What about fraction exponents? Like a root function. So when you see 1/2 as a power, I hope you're thinking that's the square root of x. If you saw 1/3 as the exponent, cube root of x. I hope you're thinking that. And you can see those. And you guys are familiar with, I would say, don't have it memorized necessarily. Inverse functions. You know how if you plotted your graph on a dotted line and you had this x squared, and then you did the inverse? Well, really, this is the sideways parabola of that. Because you don't have the negative part, you don't get the full. You only have the parabola when you do the inverse. This is the inverse of x cubed, meaning x cubed looks like this. And they're the reflection of each other along that line. Anyways, cube roots, fourth roots, etc. How about just to the -1? That's called the reciprocal function. And this basic form you use often in rational functions to figure out if you have to graph it quickly without a calculator and so on. So we got the asymptote at x equals 0, both vertical and horizontal asymptote when it's the simplest function. Now, I hope you all understand that that's what this function is. X to the -1/x. Oh, Sarah, I'm looking at you and I wouldn't, there's your notes on the sideboard or wherever. I forgot. So this is what we're going over. Rational functions. Okay. A function of x possible on the top and the bottom. Possible. Now, it's a must that q of x, the bottom denominator, has to have an x expression, x minus 3 on the bottom. You could have a constant function on the top. Or you could have x plus 1 over x minus 2 or something like that. Vertical asymptotes, Hope you realize that's where it's undefined at vertical asymptotes, and we talked about that in the previous chapter. That's where you have a number over 0 when you plug in something with the original expression. Makes the denominators. Horizontal asymptotes. If the degree of the numerator and denominator are the same, just take the ratio of the leading terms. So if I have this full expression here, 3x squared minus 2x plus 4, and it's all over, I put in 1x squared just to show something here, but x squared minus 8. Now, I have a box here, and I know yours isn't printed in color, so the rest of the stuff doesn't really matter as far as horizontal asymptotes are concerned. As long as you take a look at the lead terms, 3x squared divided by 1x squared, 3 over 1, the horizontal asymptote is going to be at 3. Okay? So it's going to look like this, and then at 3, above there, you'll have your asymptote horizontal. Okay? Now, if the degree of the top, the numerator, is smaller than the degree of the denominator, the horizontal asymptote will be the x-axis, and you're quite familiar with that. 1 over x is a good example of that, or 2x over x squared. Yeah, in this case here that I gave 2/3 is and so on. We could plot that, play around with that. Now, this is sort of stuff you've seen before, I'm hoping. Just refamiliarizing. Now, algebraic functions. That's all the categories we've seen so far. Polynomials, rationals. But this is a larger category, sort of like mammals includes cats and dogs, etc. Humans. And yeah, so this one we couldn't really give it an easy name. You know, it's got some rational parts to it. It's got multiplicity 1 on that bracket, etc. If you can't be more specific, just call it an algebraic expression. After that, trig functions are really trigonometric, full name. Involve the basic trig functions somehow. Sine, tan, cosine. You guys are aware of, but haven't ever graphed, though. Cosecant, secant, and, oh my goodness, cotangent. Anyways. So, as soon as you see that, just say trig function. Exponential functions, the x is in the exponent. So the base, b, if b is larger than 1, it'll show growth from left to right. So like 2 to the x. 4 to the x is the example here, but like, they would all, since I didn't plot points, anything larger than 1 to the x will look like that. Then you'd have to get specific points. By the way, it doesn't matter if I had 2 to the x, 4 to the x, 1,000,000 to the x. What is it when it's x equals 0? Guaranteed 1. Okay. As long as there's no multiplier in front of that. If you had this bracket and then had a 2 in front of it, it would multiply every value times 2. Okay. If the base is between 0 and 1, so half, a third, a quarter, etc., 3/4, you're going to show decay, or it'll drop from left to right. So there's 1/3 example there. That's the way a lot of them will look. But you might not have it given as a fraction. You might have it given like this, 3 to the negative x. Once you see that negative sign, you might think, okay, this, do the reciprocal, and that makes it positive. So often you'll see decay. Now, we're not going to come across these too often, so don't worry. But I know you've seen those before. We're going to be able to just identify these equations. Log functions have a log in it. There is going to be a log later on that we'll see you've never played with, but you've seen it on your calculator. You've seen this button on your calculator, and I know Hashim has, but you've never really used it. Have you guys ever used e to the x or natural log of x? No. Okay. Sometimes the teacher might just throw it in just because they know you might see it in calculus. Okay. And if the log base is larger than 1, it's going to grow. There's absolutely no negative values in here. Nothing. this side, right? Likewise, here, log to the 1/3 x. So when the base is less than 1 but greater than 0, you get something like this. Okay? That's what log functions look like, the general picture. Transcendental functions are not algebraic. That's the categories we were just looking at: trig, exponential, and logarithmic functions. Those are the vocabulary kind of things here. Now, do you guys have this? Yeah. Can I give you guys a minute to go through these and be as specific as possible? So like you could say algebraic for some, but you can probably be more specific. And I'll ask you to be the most specific. So as soon as you see this one, what do we say? Okay, you got 6 points for you. Reciprocal. 2 points for Gryffindor. I said 6, I took 4 away though. Okay. Now, can you guys run through these? And I will quickly, okay, to run through the others. I think it's pretty simple. Can you do these without flipping back and forth is eventually the point you want to get to, through familiarity. Logarithmic. Linear, you could say the identity function. I'd accept either one as most specific. Identity means it returns itself. Did I miss that page when I went over the functions? I did, didn't I? Okay, I must have flipped through it. What else was on that page that, or it was, did I go through the page and just miss the identity function? I just realized. Yeah, okay. If you put in 3, you get out 3. If you put in -7, you get out -7. Identity itself. This is a root function, given as a fraction exponent, a root function given in the old-fashioned symbol. The last one, what do we got? Good, constant. Oh, L and V, yes. Root, because that means the 7th root of x when you got a exponent. And of course, this is a 4th root here. So yes, a constant for the last one. Don't automatically assume if you see an exponent that it's exponential. Okay? Whereas 6 to the x, that would be. Now the last thing, I'll just go over the pictures and why I have them. I'll shut this up.